webinars. We've got a talk by Martin Berry on the Bacton Outfall, quite a prestigious outfall that won the Outfall Award this year for the Pipeline Industries Guild. It was in the news quite an awful lot in the year it was being built, and it's quite a project. We've got a series of these that if you want to look at the up and coming ones, look on the Pipeline Industry Guild website, or if you go on YouTube and tap in Pipeline Industries Guild, we've got all the previous ones downloaded. Martin, over to yourself. Thank you very much.
Okay, thank you, Sean. Hopefully everybody can hear me and see my slides. So yes, my name's Martin Berry from Royal HaskoningDHV. I'm a principal engineer in the marine pipelines team that we have. And this is the project that won the Pipeline Industries Guild 2020 Project Award. And it's about the Bacton combined outfalls. Bacton, as Sean said, was in the news quite a bit last year, and that's mainly to do with the sandscaping project, and the outfall project was linked to that. And as you can see from the top, there was North Norfolk District Council, Shell, Van Ord and Prenco involved with this project as well. And I will explain as we go along, basically, hopefully. Right, so what I'm going to talk to you today, I'm going to give you a little bit of a background to the project. I'm not going to try and go into too much detail on the sandscaping scheme, but I suspect you'll probably be interested in that anyway. We're going to discuss the marine outfalls, basically some of the challenges we've faced and the solutions. If you do want to know more about the sandscaping scheme itself, the technical experts within Haskoning is a chap called Jaap Flipwert. He did a UK water project paper last year, so that's available for free on the UK Water Project's website. So if you want to know more about that, I wasn't overly involved with the sandscaping itself, but I obviously know enough to discuss it at high level today. And it did actually win the NCE 100 Innovation in Project Award last year as well. So Bacton is in the Norfolk coast, basically in the UK. The challenges that Bacton faces are eroding beaches. So sea defence failure and loss of the cliffs. The North Norfolk coastline, is renowned as a dynamic coastal area, and there's a lot of erosion going on. The Bacton terminal itself, as you can see just to the north of Bacton village, is national important gas infrastructure, and it supplies about 30% of the UK's gas demand. So obviously it's of high national strategic importance. So the Bacton itself, it's a dynamic coastline, North Norfolk. There was a big storm in 2013, and that lost about 10 metres of the cliff in the area around the terminal. There was damage to the sea defences. Homes and businesses were damaged. There was loss, houses were lost, and there was flooding. So obviously there's concerns from the community around that area, around the coastal defences and coastal erosion. Say 30% of the UK's gas comes into the Bacton terminal. So there was an urgent need for a solution for both the terminal and the villages. It also became clear from the shoreline management plan that there was, the conclusion was that sort of 10 to 15 years, the villages would have to be abandoned to the sea. So that would have been about 300 homes within the coming decades would have been lost. It was, a scheme to protect the area was required quite urgently. So what was proposed? Well, the Netherlands gave an opportunity here to look at a different solution. So they have something in Holland that they call the Zand motor. In theory, the sand motor. There's an aerial photograph of it. So it was something that was done that created a 70-meter wide spit out into the sea to provide a protection, almost a natural protection to the coastline. So the idea of these projects really was to avoid making things worse to the neighbouring communities. So our expertise from Holland looked at this innovative sandscaping project. So it looked at the opportunity to design a similar scheme at the terminal, which would benefit the surrounding communities. The idea really is to look at a natural process on a large scale. So instead of building hard physical defences, which are expensive, it's looking at a natural solution that halts coastal erosion, but actually restores the beaches and creates an amenity and gives protection to the villages as well. So for Bacton itself, there was a proposal for this sandscaping or sand motor, and you were looking at around 1.5 million cubic meters of sand in total to restore the neighbouring village and beaches, to sort of halt and slow down the erosion. This would provide the protection to the local communities, but it also provides something innovative and actually give them a recreational and facility. So, the advantages were obviously it was a reduced cost. The nourishment is a cheaper option than doing hard defences. It reduced the disturbance to some of the local habitats. So it provided both a tourism and a recreational benefit. And it provides new habitats to the amount of sand that is generated and created on the beach. So this is the Bacton coastline before the sandscaping. So you can see Bacton and Walcott sort of to the top left-hand end of the screen and the terminal down on the bottom right-hand side. And this is the impression of what the sand engine and sandscaping will be in the final. So you can see it was slightly wider around the terminal and slightly narrower going in front of the villages. So it was sort of between 1.5 and 1.8 million meters cubed of sands and gravels, which would be dredged from licensed dredged areas offshore. And for the terminal itself, it would provide a high protection level and potentially wouldn't need re-nourishment until 15 to 20 years time. Obviously that is subject to what the weather conditions will be and how the coastal process is modified over the next few years. And then for the villages, it obviously then gives them a higher beach, it has slowed down the erosion, and it gives them something, to adapt for the future. Gives them time, basically. So this is a section through just to show you. So the beach level, certainly around the terminal, is increased by about 6 or 7 meters, and you end up with anything up to 70-meter wide beach. It's 40 to 50 meters wide typically. But there's a lot of material there that will be built up on top of the existing beaches. And just to give you what we do here is this is giving you an impression of what it would be like to fly, and this is an impression of what the new terminal, the new beach level would look like. You can see the terminal on the left. It gives you an impression of what the state of the cliffs are as well. On the existing beach, you can see there's a timber revetment and there's a number of timber groins, and actually you can see the existing outfalls as well. But this sort of gives you an impression of what the beach would look like when it's completed. So let's talk about the actual existing outfalls themselves. So at Bacton Terminal, there are 3 actual separate operating companies, and each operating company and terminal has an existing outfall. These outfalls are basically a combination of sort of surface water and some processed water from some of the processes on site. We're not talking of large flows here. The existing pipelines are 24-inch cast iron. Some repair works had been done to them. Some sections had been relined, and they were constructed across the beach, basically in timber trestles. So the photograph on the right shows one of the pipelines going out in a timber trestle, and they extended just beyond sort of the low water mark, about 120 meters across the beach. And they were in various conditions. They had experienced some damage. The disadvantage with these timber trestle structures is, you know, most of these in the UK are probably over 40, 50 years old, and they're in the breaking wave zone, and they do eventually end up damaging the pipes, and you do get pipe failures and joint damage and repairs. So they're not as robust as pipelines that are buried. Of course, when the sand engine, as you've seen from the previous slide with the profile, is we're going to extend the beach, there's 6 or 7 meters worth of sand going to be buried on top of these pipelines, and basically the low water mark is going to move further offshore. So these existing outfalls will no longer be able to discharge to the sea because they're basically going to be buried under sand. So they all needed extending. Basically, you're looking at probably about 150 meter extension was required so that they could then be extended beyond the sand meter and continue to discharge. It's quite a good photograph here just to show you as well it gives you a bit better impression of what the condition of the cliffs are. As you see, there was collapse of cliffs in front of the terminal. There'd been some temporary stabilization works done a couple of years ago just to try and stop some of the toe erosion. And you can see the existing timber revetment there across the beach and some of the groins and the existing outfall. So this is sort of at the south end of the terminal looking north. So some of the challenges we faced, well, we have 3 different operators, so there's 3 separate approaches were required at the initial project phase. So each outfall was to be dealt with as a separate item and as a separate extension exercise. Each outfall had different flow and operating regimes. Some had more processed water than others, surface water, you know, rates varied. So again, it was, you know, there was different values between the different operators. As you can see, we've got steep and unstable cliffs. The profile of the cliffs varies along the length of the terminal. We're also in the breaking zone here, so intertidal zone. So whatever solution we have, we are going to have to counter for breaking waves and breaking loads on whatever the discharges location is going to be. One of the other big challenges is actually what's the incoming gas infrastructure. So basically, as it's a gas terminal, all the gas is getting fed from offshore gas fields. So there is a large number of incoming pipelines underneath the beach, which are obviously high strategic importance and mustn't be damaged or interfered with under any circumstances. You can see the existing revetment there, which had to be crossed. There are a number of environmental constraints, particularly around the cliffs and some of the designations, and there's a nesting area for sand martins, which we'll get to later on, and also construction constraints. You know, there's no local ports nearby, storage facilities were quite restricting around access onto the beach and what we could and couldn't do around the beach. So that all had to be taken into consideration. So the initial approach in the early stages of the project was to look at single solutions for each pipeline. So typically we were looking at around a 350 polyethylene pipe, about 200 meters in length, which would take you beyond the end of the sandscaping. These would be installed offline next to the existing, so you could allow the existing to maintain operation and then basically just switch over, and they would be installed using the float and flood technique, which I'll explain later. This would all be done before the sandscaping, obviously. You discharge basically through a single discharge arrangement, which would have a multi-port configuration. The other challenge really was how far back did we relay the pipelines? For all three operators, they have a collection system on their sites, which will either go to a terminal, pumping station or tank or manhole system before it then discharges down the existing. So for each one of these, they have existing pipes that have already been laid through the cliffs. One thing we really didn't want to do was have to relay those sections through the cliff. That would have been a major construction project, quite a high risk with the unstable cliffs, or may have had to look at drilling techniques or something like that, which would probably have forced us back in further into the terminal. There's also security issues as well working in the terminal, so that was quite a challenge. But fortunately, the operators had all surveyed and had quite good condition assessments of their existing pipelines, and a couple of them had actually already been relined with polyethylene sleeves. So actually those sections didn't need replacement. So it allowed the new outfall pipes to basically be connected at the bottom of the cliff. So we didn't have to do any work through the cliff. So, and to conclude, really, for each individual pipe solution, outfall solution, you were looking at around £3.5 million per outfall, if they were done as individual projects or individual installations. So for 3 projects, you're getting close to sort of £10 million for the 3 pipelines, which is quite a bit of money. So one of the options that was put on the table was then to say, well, why don't we combine them and just provide a single outfall, which may seem quite logical, but obviously with 3 different operators, you've got 3 different consents, 3 different water qualities. So there's quite a lot of regulatory and legal aspects around that to resolve. But we came to the solution basically of locating a single outfall at the southern end of the terminal, and that would be a 560 mil SDR21 HDPR pipe, approximately 250 meters in length. And what we actually found was we extended the length of the outfall 50 meters, just about 50 meters further than it in theory needed to be to actually get us into some deeper water. We were struggling to, because of the breaking wave zones, we were struggling to get the stability of the diffuser and diffuser protection to work. So we ended up actually extending it 50 meters further just to give us into slightly deeper water and reduce some of the loading conditions. So we have an outfall at the southern end, and then we had an interconnecting pipe that ran along the top of the beach, and basically that would connect to the other 2 terminal operators and bring the flows to this single discharge point. That interconnector was about 750 meters in length. The downside of that interconnecting pipe is it had to cross a number of the incoming gas pipelines. So there's existing infrastructure there that had to be crossed. The profile of that interconnecting pipe was fairly flat as well because of the restrictions on the beach and the levels and connection levels, etc. So there's a number of air valves that were going to be installed in there to make sure we can get the air out of it. And this combined scheme of the interconnector and a single outfall approximately gave you about a 50% cost saving on the overall scheme. So fortunately, it was something that the operators, were able to come to an agreement on with regards to the consents and the legal aspects, and it was something as well that the Environment Agency signed up to as well, and were happy with and consented. So which was great. So we went forward with the combined solution. Some of the construction challenges that we have for the site was, as I say, it's quite a remote site. We're not right next door to a port or anywhere that's easy to service. Again, even just getting there by road is quite a challenge. There's quite a few country lanes to get to the site, to say the least. So we had no large area available for pipe fabrication, and being able to string and weld the pipes out. With regards to the actual terminal, obviously it's strategic importance nationally, so there's a high security presence at the site, and working, going and actually working within the terminal had to be minimized as much as possible because of both the security and the health and safety aspects of working in the live terminal as well. So there were security issues. We had to work around the existing infrastructure and gas pipelines. The beach is still a public beach. There's also a public footpath that runs along the top of the cliffs as well. So there's that public interface. The public is also very interested in the scheme as well. The cliffs, as I've shown already, they were unstable cliffs, and there was still potential for further collapses during the construction. So we obviously wanted to make sure we weren't working right underneath the cliffs or undermining them or doing anything that might affect the cliff stability. Ground nesting birds, there's obviously during the summer there's issues around ground nesting birds, and the cliff itself at Bacton is a large nesting site for sand martins. It varies along the sections of cliff about where the sand martins are, but they are present, and I will touch on this later, but I don't want to go into it in too much detail. But there were areas of the sand martin nestings that were going to get buried by the sand engine anyway. So anything in the bottom 6 or 7 meters of the cliffs was going to be buried anyway, and that section was all netted off and prior to any of the works going to prevent the sand martins from nesting prior to construction happening in the summer period. This scheme had gone through full EIA, all the licensing processes, full consultation with RSPB, Natural England, etc., etc. So, there was a lot of environmental hoops that we would jump through already to discuss and understand what had to be done with regards to particularly the nesting birds issue. Just let me go to the next slide. So we started construction, and the first thing we do was basically the fabrication of the offshore pipeline. So this was done in Great Yarmouth, and because of the relatively sort of short length of the outfall, it was provided in individual sections of pipe manufactured in the UK, 12-meter lengths, which were then welded at the yard in Yarmouth into a long string, and then these are the concrete collars being fixed around the pipe. So Van Ord, who were the contractor on the project, they actually created this little rig here. This is actually, you can see my mouse, this is a lifting table. So what they actually do is roll the collar in here on a set of rails, the bottom section, it's lifted up. They then can bring the top section over, bolt them up, and then drop the floor, and then it gets pushed out. And this allows the collars to get added on the pipe. So for polyethylene, it's a buoyant material, so you have to add these concrete weights to both be able to sink the pipe and provide long-term stability. So this is the length of pipe being fabricated in one piece in Yarmouth, and you see it's capped at both ends and it's full of air, slightly pressurized, so it's just floated out into the harbour until the whole string is ready and prepared, and then it would get towed around to the Bacton site. So that's the prep. So this is the morning of the installation for the new outfall, and this is about 5 o'clock in the morning on the 16th of June. So the installation would take place over the slack tide of high water. So the backhoe dredger that you can see here is located at the offshore end where the discharge is going to be. The pipe's been towed round and brought inshore, and it's connected to this excavator here to hold the onshore end. And basically this multi-cat and this tug are slowly moving back, and the offshore end will be attached to the end of the backhoe here at this end. And as if by magic, this is what it looked like when it was all lined up. So the pipeline's positioned onshore, positioned offshore, and this is just being held in position waiting for the slack tide, which was, I think, about 8 o'clock in the morning. So we towed the pipe round, got it ready, pulled into position, ready for the sink. You can see some of the other works that's going on around the cliff and the pipe installation here. So that was ready for install. And then this is the installation, basically, that the pipeline is basically flooded with seawater from the offshore end. So there's a pump at the offshore end that will pump water into the pipeline through a bulkhead, and you slowly sink the pipe from the offshore end to the onshore end. And here we've got a really complicated system of a bulkhead and a piece of flexi hose, basically, that's raised in the air. So this is expelling the air out of the pipe. It does actually have a pressure gauge on here as well, and there's obviously control valves in here. There is also, this is an example, so you create what's called an S-curve. So basically, as you flood the pipe from the offshore onshore, you fill it up with water. There's usually a soft pig, so there's a little soft pig that is in here at the water-air interface, and that slowly moves inshore as you start to pull. There's a very, as you can see from here, there's a very gentle pull force. It's just slightly held in tension by the excavator bucket here. This is purely just to keep the alignment and also stop the pipeline from moving offshore. But if you're in very calm conditions, as you can see here, it was flat calm, you know, that makes it a lot more beneficial. So this is the S-curve flooding, and it literally took about 40 minutes to flood the pipeline. And this is the final position of the pipeline once it was sunk. You can just see the remnants here of the offshore trench that had been prepared, and that goes all the way offshore. There was, because the beach was very flat, we had to reprofile the beach slightly. Not so much at the offshore end, but there was some reprofiling here just to make sure that we didn't have any intermediate high points or a very flat pipeline that had a risk of trapping air. So there was some sort of local trenching done across some section of the beach, just to really for the hydraulic benefit, but it was fairly minimal. And what happens here, this line here is the existing pipeline. So obviously we need to connect this to the existing pipeline. So once this was actually sunk, this was realigned and moved over here. So there was sort of a horizontal S-curve that came so that we could connect up to the existing pipeline. And this is the survey vessel, which is now just doing a survey of the pipe to confirm its final position. And so this is the interconnector being installed. So this is looking from the southern end up towards the north. So this was installed basically as close as we could to the existing revetment to keep us away from the existing cliffs. And it was a 560 pipe for the majority of the length, and actually was the top section was only a 250 diameter. This was, you can see the bottom right, this was actually welded on the beach, so there was a welding tent set up, and the welding was actually done on the beach to help that, and it was still had to have some concrete collars put on it to make sure we overcame any buoyancy effects in the temporary and the permanent condition, because obviously the tide will come in and the water level here will rise, so we didn't want the pipeline floating along this section. So that's the interconnector being constructed. And then the final challenge is to do the connections and connect everything up to the new outfall. So this is the southern end. So this is the interconnector coming in basically. So this is bringing the flow from the other two sites. This is the existing southern outfall all coming together at one single point. And then this is the, say there was an S curve. So this is basically going offshore there to the new alignment, basically. So this is all the new outfall pipe. And you can see here, this is the existing pipe that's been capped and disconnected, basically. So this is all the final connection works, and this section, this is here is the one of the air valves. So basically, there's a pipeline that comes out of here vertically and extends all the way above the proposed beach. So that will provide some of the venting of the air. There was another one about halfway down the interconnector, basically. So that was the final sort of act to connect all the existing pipelines up, get the air valves in, and basically get this backfilled. And that then allowed the sand engine project to follow. So this is an image of some of the sandscaping once it started. So this again was done by Van Ord. They had a dredger working from offshore dredged license, and then they had a steel pipeline that basically delivers the dredge material onto the beach, which is discharged onto the beach, and then local dozers then start to level it and build the level up to the new proposed sandscaping. So that's a photograph from the top of the cliff showing you the dredger. So this was the HAM 318, which is one of their largest dredgers, which was available because it had been doing some work in Europe and was made available. So that's been off to one of the offshore sites, full of sand and gravel material. You can see there it connects up to the sinker pipe, which basically they pump the material back on shore. And then it's leveled on the beach, and then this pipeline is obviously adapted as the work up and down the cliff. They were dredging, say, about 1.8 million meters cubed, so it took 5 weeks and 3 days to do all the dredging. That's approximately 47,368 meters cubed a day, approximately. So it's quite a lot of dredging material. And this is near enough the final profile of the beach. It was actually quite difficult to get a final image of it, but this is at the terminal end, and you can see how much the beach has been extended, and obviously it continues beyond the low water mark as well. Anyway, you can't, you know, so but you see it's quite a difference to how the beach is, and this is this material will be leveled out and sort of find its own natural level, but it is quite impressive to see. Well, that's the finish. So the outfalls are underneath there, basically 6 or 7 meters underneath there. Was the finished. The air valves themselves, by the way, were positioned right at the bottom of the cliff, so they weren't sort of things that were going to stick out in the middle of the beach. We routed the pipework so that the actual air valves were back, and hopefully that will reduce the risk of any vandalism. And I think this is near enough my final slide. We've got a little bit of a video that I'll just show you at the end, which is about 3 minutes. So I think Sean touched, and some of you may have been familiar with Bacton because it did unfortunately hit the news. I've put an extract from the BBC website. Chris Packham, Simon King from the BBC Wildlife Unit as well got involved. They came to site, and it was on BBC website, it was on BBC News, it was on the One Show, various other bits and bobs. This was mainly around the netting and the San Martins, etc. I don't want to get too dragged in it. So there's a photograph here on the top left hand. This is one of the protests that they had on the beach. So there were some issues and publicity around the San Martins and that were sort of negative. But as I say, a lot of this and the procedures were all agreed. Yes, there were some modifications done. There was also quite a lot of risks taken by some people climbing up cliffs and removing netting. But there was a lot of it was around misinformation and people getting carried away on social media, and it's surprising how quick it can escalate. But on a positive side, the residents Bacton and Walcott, they were very much on board with the scheme. They certainly, once the dredger arrived, which was one of the largest dredgers in the fleet, you typically don't see a dredger of that size working in the UK very often. They almost became dredger spotters, and they were monitoring the dredger, and they got loads of things going on Facebook around it. So there were some very positives from the residents and the local community around the actual scheme once it got going and dredging. And you see this is the opening ceremony, and they had this artist that came in and he actually did a sun sculpture of the dredger. So it was something that the residents were really sort of got on board with regards to sort of the dredger and the works being done. As I say, last year it won one of the NCE awards as well. So I think one of the things out of this, really, there's swings and roundabouts, there's positives and negatives, but with regards to this, but you can see certainly with social media how things can get out of control very quickly, and certainly on misinformation as well. Okay, so there is one final video I'm just going to show, and I have to do this from, hold on a second, I just need to do this from YouTube, because it doesn't run very well from, hopefully this will work and you can still see this. This has been done by one of the photographers that Van Oord employed, and he did a bit of a drone video, and he put it to some rather epic music as well, so it's a bit like Lord of the Rings, but this hasn't got anything on the outfall, it's just got the sandscaping. So hopefully this will play. Okay.
Great talk, Martin. Thank you very much.
No
Really
problem.
appreciate it. Couple of questions on the in the chat window. If you have got any questions you want to ask, just put a question in the window on the right hand side. A couple of them coming already. First one from Bill Clisham. Given the volume of air that has to escape from the pipe as it fills and empties with the tide, what type of air valves were installed?
They were just basic vent pipes. There was no sort of actual orifice type air valves at all. It was just natural vent stacks basically that were extended above. They didn't want any infrastructure down on the beach that they were going to have to maintain or you know, or potentially going to corrode in that saline environment. So they were just purely pure vent stacks.
It's almost like a snorkel.
Yeah, they were. Expensive ones because they were in stainless steel.
Next question from Mike Armstrong. In reference to the stability concerns at the diffuser location, could you confirm the stability assessment was undertaken in line with DMVGL 109?
Yes, it was. Actually, the stability issue was more to do with the diffuser dome. So this was the concrete dome that had to go around and protect the diffuser itself, and it was in the end, it was done in multiple sections so that it could be lifted and installed and then bolted together so that it could then provide the overall weight and stability. So yes, everything was done to F109.
Next one from myself. Was there any anti-fouling related to pipe?
No. I mean, it's, you mean concerns about marine growth?
Yes.
No, I mean, it had tide flexes on the offshore end. We hydraulically designed it so that there's an allowance in the roughness for some marine growth and sliming. The advantage is one of the operators has storage tanks and a pumping capability, so the system could be flushed if it needed to be. No, generally the tide flexes try and keep the saline out as much as possible.
No problem. I think that's it from the questions point of view. We've got another talk coming up on Thursday, which is about the H21 and the hydrogen gas network. I'm just reading quickly. There's a couple of things popping up. I think they're all just compliments and thank yous, Martin. So I appreciate your time today.
No problem.
Cheers. See you all on Thursday, hopefully. Bye-bye.
Thank you.